Hi all, welcome back to another video from Cracking the FAANG interviews. Today I'm going to be talking about Leetcode 746, which is minimum cost of climbing stairs. This is a popular problem from Amazon, Google, Microsoft and Netflix interviews. If you haven't already, please check out the climbing stairs problem, which is not the minimum cost problem. So this problem is an extension to that problem. I'll leave a link to the problem in the description below. It builds on this problem builds on the fundamentals we have established in that problem. Yep. Let's look at the problem. Again, here I have a snippet from Leetcode. So what we've been given is a staircase where each step has a cost associated with it. So if I were to draw this for you, the way it would look like is step 1 has a cost of 0. You can index this as step 0 in programming. Step 1 or step 2, but let me just refer to indexes to keep it simple. Step 1 has a cost of 15 and step 2 has a cost of 22. And what they're asking you to do is you can the constraint here is you start here or you start here, and you're allowed to take one step or two steps at once. So if you start at 10, you can directly go to 20, or you can go to 15 and then 20, essentially. This is the constraint of the problem. What they want you to do is pick where to start first of all. So if you want to start at index 0 or 1, make that decision. And once you decide that, you essentially find the minimum cost sequence. So if you remember, in the previous problems I've mentioned, whenever you hear the words like number of subsets or number of ways or minimum cost or anything with minimum or longest, any superlative words, right, like minimum, maximum, longest, smallest, you need to be exhaustive. Meaning, to find what is the minimum, you need to figure out everything else, right? If that makes sense logically. So the only method you can use for that is usually recursion. And recursion is essentially exponential time algorithm. So it could be O of 2 power n as previous problems that we have solved. And the way you convert this into more like a polynomial runtime, meaning optimize, is dynamic programming. And again, if you haven't checked out my previous videos, I highly encourage you to start with the recursion and dynamic programming series, which this video is a part of. I have videos where I cover fundamentals with the Fibonacci program, then climbing stairs, and then this minimum cost climbing stairs. So this is a dynamic programming question. And to quickly summarize, the reason I think it is dynamic programming is I've been asked a global answer, minimum, right? So I have to figure out all permutations of climbing to say which one will give me the minimum. Awesome. So let's dive into the code. So as I've always suggested, whenever you're writing code with a dynamic programming solution, you always need a base case. And this base case comes from the recursion, right? So think about it this way. You have this sequence of steps given to you, and I'm going to quickly draw this again. The costs were 10, 15 and 20. And what you're doing is you're essentially this can also be represented in an array. So for step 1, 2, the cost is 10, 15 and 20. What you're asked to do is essentially find out what is the cost to get to 2, the final step. And the constraints given were you can take one step or you can take 2 steps at once. if that makes sense. So let's try to, since we said this is recursion and we are now directly writing optimized code for dynamic programming, we need to solve sub-problems. So what I mean is sub-problem could be just, you're given 3 steps, just think of 1 step at a time, right? So for this step, what is the minimum cost? You're required to start either here at the 0th step or the 1st step. So the minimum cost here is going to be 10 because you don't have any other alternative if you're just looking at this sub-problem. But now if you're at index 15, what is the minimum cost of getting to index 15? So the minimum cost could be directly jumping, starting from 15 itself, or starting from 10 and then going to 15, right? So that's how I've represented this here. If the cost is 10, you can either have the cost for the step 1 as 15 plus 10 or 15, meaning you start at 15. So you calculate that using this formulation. In this case, the minimum cost, it will make sense to directly start from the index 15 rather than come from jump from 10 because it's going to add its own cost. All right. So we solved these, the sub-problem till here now by solving the first sub-problem for 10, then the second sub-problem for 15. Now let's solve the third sub-problem or the problem of getting to 20. Again, for getting to 20, right, the minimum cost could be starting at 10 and then taking 2 steps. You can take 2 steps jumping to 20, or starting at 15 and then taking 1 step. So the answer would look something like minimum 20 plus minimum of cost I minus 1 and cost I minus 2, if that makes sense, where cost I minus 2 is the previous minus 1 and minus 2 are the previous 2 solutions. And that's exactly what I've written here, if you see, as I go through the array. And what I'm essentially doing is, in this case, what would make sense is starting at 10 and taking 2 steps and directly going to 20. So the cost will be 30 versus it could have been 35 if you had started, picked up from 15. So essentially, what we are doing is we are looping, we set up the base cases first, the base cases. And then we start from index 2. So this is 0, 1, 2. We start from index 2 because the base cases for the previous 2 steps are set up. And we iterate to n plus 1, which means we iterate till n, step n. And if we are at the last index, we essentially just pick the cost of the previous 2, meaning if you're jumping here, which is the last index n. So the question is actually asking us to go beyond these 3 steps here. So there's one extra step you need to make here, if you just look at the example in the previous question. But I've also seen a variant where they want you to get to the top step. So both of these questions are valid. That's why you have an extra n plus 1 in the solution here itself. And what you're doing is, essentially just picking your current cost and evaluating based on previous sub problems from where should I pick or jump to get minimum cost. So you are looking for minimum. You solved all possible sub problems. You're combining that to get your final result. So the runtime for this is going to be time complexity is going to be O of n. Again, here we directly wrote the optimized dynamic programming solution. You could also have written recursive solution and then optimized it as we discussed with dynamic programming. But the concept and the expression remains the same. Yeah. I hope you liked the video. Thank you for watching Cracking the FAANG interviews. Please like, subscribe, and share the video with your friends. And leave a comment down below if you need any help understanding this problem.